Hey 7th grade. In this next video we're going to continue our discussion of functions, and in this video I want to specifically talk about how to write a function rule or how to write an equation given a table of values. And so what we're going to do is we're going to take all of those different function families that we talked about in the last video, and we're going to separate those into two different categories. We're going to separate them into what are either linear functions, which again are the functions that give you lines, or nonlinear functions, which would include every other function family, your quadratics, your cubics, your square roots, etc. And so we're going to add one more thing to our characteristics of those two different types of functions. So one thing we're going to add to our family of linear functions is this. A function is linear when its rate of change, okay, its rate of change is constant. Function is linear when its rate of change is constant. Another word for constant is the same. A function is nonlinear when its rate of change is, guess what? Not constant. Okay, so a nonlinear function would be one whose rate of change is not constant. And so, first thing we're going to do is we're going to talk about what we mean by rate of change. Well, the rate of change, when we're defining rate of change for functions here in algebra, it is defined as this. It is the change in each output value, or y value, divided by the change in each input, or x value. Okay? The change in each output or y value divided by the change in each input or x value. So let me show you what I mean down here in these next few examples. For each of these examples 1 through 6, I'm going to give you a table of different x and y values, or in this case for 1 and 2 they're written in f of x function notation, but again f of x means the same thing as y. And so what we're going to do here to determine whether or not these are linear or nonlinear functions is, first of all, we're going to determine what the rate of change is from one set of x values to the next and one set of y values to the next. Okay, and then after we determine that, we're going to tell whether or not that rate of change is constant. If it is, we know we'll have a linear function. If not, we're going to have a nonlinear function. Okay, so for number 1 here, we have ordered pairs of 0, 5, 1, 7, 2, 9, 3, 11, and 4, 13. So I'm going to concentrate just on the y values first of all. Okay, these values over here, 5, 7, 9, 11, 13. And I'm going to ask myself, what is the change from each y value from one to the next? Well, starting with 5, from 5 to 7, the change is that I'm adding 2 to go from 5 to 7. And then from 7 to 9, the change is that I'm adding 2. From 9 to 11, I'm adding 2. And from 11 to 13, I'm adding 2. So it would appear that the change in my y values is constant. But when I'm thinking about rate of change, I need to think about the y values compared to the x values. Okay, a rate means that you're comparing two different changing relationships. So now I need to look at my x values and ask myself how they are changing. So my first x value is 0. My second x value is 1. So from 0 to 1, I'm adding 1. And then from 1 to 2, I'm adding 1. From 2 to 3, I'm adding 1. And from 3 to 4, I'm adding 1. So to find the rate of change from one set of ordered pairs to the next, what you're going to do is you're going to take that change in the y value divided by the change in the x value. Okay, so our first rate of change for this particular table over here, going from this ordered pair 0, 5 to this ordered pair 1, 7, was a change of 2 for my y values divided by a change of 1 for my x values. 2 divided by 1 is 2, and so we had a rate of change of 2, we say. Okay, then I have to look at the rate of change from my second ordered pair 1, 7 to my third ordered pair 2, 9, and do the same exact thing. Okay, so for my next ordered pair I had 2 for the change in my y value, and over here I had a 1 for the change in my x value. So again, I got a rate of change of positive 2. Okay, I'm going to do that again for the third to my fourth and the fourth to the fifth, and each time I find that I get, every time my y value increases by 2, my x value increases by 1. Okay, so I keep on taking 2 divided by 1, 2 divided by 1. So each time I get this same rate of change value of plus 2, and what that means is that my rate of change for this entire table here is constant. Every time you take this change divided by this change, you get the same number, 2, and so that means we have a linear function here. Okay, here in a second we're going to go back and we're going to talk about how to write the function rule for each of our linear functions, but for right now I just want to focus on this part A here, determining whether or not each table represents a linear or nonlinear function. So let's look at number 2 now and do the same exact thing. Starting with -1, this y value here, we're going from -1 to +1, and that is a change of 2. So I'm adding 2 there. Okay, now I'm going to look at my x values for that jump. I'm going from -2 to 0, and -2 to 0 I'm also adding 2. Okay, so our first rate of change here is 2 divided by 2. Okay, this y value divided this x by this x value, and that gives us a +1 rate of change. Okay, so far I've got a +1 rate. Now I'm going from 1 to 4, so that's a change of 3. And then for my x values, I'm going from 0 to 2. That's a change of 2. That right there should tell you that something is off, because up here, when we went up 2 for y, we also went up 2 for x. This time we're going up 3 for y, up 2 for x. Okay, 3 divided by 2 is not equal to our 1 that we got up here, so that means that this is a non-constant rate of change, and therefore we have a non-linear function on our hands. Okay, whenever we have a nonlinear function, I'm not going to even bother by writing the function rule, okay, because what I want to do is concentrate on the linear function, since that's going to be our next unit of study here. So if any function here is nonlinear, we're not going to do part B here. Part B says if the function is linear, write a function rule, so I don't need to do it for my nonlinear functions. Okay, going on to number 3, and then again we'll come back to the function rule parts. I'm going to go from 15 to 5 here for my change in y values. So from 15 to 5, I'm subtracting 10. And then here from -3 to -1, I am adding 2. To get from -3 to -1, you need to add 2. So my rate of change for this these first two ordered pairs is going to be -10 divided by +2, which gives you a -5. That's my first change here, is a -5. Next, I'm going from +5 to -5, so that's a change of -10. And then over here, I'm going from -1 to +1. That's a change of +2. Well, again, we have -10 over 2. That's also going to get us -5, so that works. Next, I'm going from -5 to -35, which is a change of -20. Or excuse me, that'd be -30. And then over here, we're going from 1 to 7, which would be a change of +6. So at first, it looks like I have a non-constant rate of change here, because all of a sudden, instead of going down by 10, I'm going down by 30. But I'm also changing what I went up by on my x side. Instead of going up by 2, I'm going up by 6. So this is why that term rate is important. If we take -30 divided by this +6 over here, -30 divided by 6 is still -5. So that rate of change is still constant. And then finally, I'm going down 5 from -35 to 40. Over here I'm going up 1 from 7 to 8. And so we have -5 over +1, which gives us, again, -5. So that means I have a constant rate of change for my table here. That rate of change is -5, and so this would be an example of a linear function. Number 4, I'm going from 25 to 22 here for my first jump in y values, so that's going to be going down 3. And then for my x values, I'm going from 0 to 3, so that would be going up 3. So we have -3 divided by +3, which gives us a -1. And now we'll compare that to our other jumps. 22 to 18 is a difference of 4, -4, so we're subtracting 4. And then 3 to 7, I'm going up 4. So we have -4 divided by +4, which gives us -1. Now I'm going from 18 to 17, so that's -1. And then over here from 7 to 8, that's +1. -1 divided by +1 is -1. And then finally from 17 to 14, I'm going down 3. From 8 to 11, I'm going up 3. -3 divided by +3 again gives us a rate of change of -1. So that means that my rate of change here is constant. Okay, it's -1, and so again I have a linear function on my hands. Okay, the last two tables, 5 and 6, I want you to do the same thing I did for 1 through 4. Just go ahead and find out whether or not the rate of change is constant for each of these tables here. If it's constant, you know you have a linear function. If it's not constant, you have a nonlinear. So go ahead and pause the video, try that, and then click play to check your answers. Okay, for number 5 here, I'm going from 5 to 10, so that's +5. And then over here from 0 to 3, that's +3. So that's going to be 5 over 3, or a rate of change of 5/3. But then for my next jump in ordered pairs, I'm going from 10 to 20, which is a change in +10. And from 3 to 6 over here, which is 10 divided by 3, which is 10/3. So here my rate of change is not constant. I've got 5/3 compared to 10/3, so that means I have a nonlinear function for number 5. Number 6, however, we do get a constant rate of change. -9 divided by +3 is -3. Again, you get -9 divided by +3 here. -18 divided by +6 is also -3, as is -27 divided by +9. So for number 6, you have another example of a linear function. Okay, so now we're going to do something a little bit different. We still need to talk about the function rule part of some of these tables here, and we also are doing a function rule for number 7 here, this word problem. What I'm actually going to do is I'm going to stop the video here, and then we're going to talk about the rest of these notes in class, because I want to get a little bit more detailed and a little bit in depth in terms of how we go about writing the function rule here, and I want to make sure I'm doing that with you in person rather than through the video. So if you're through what we've done through already on the video and you're okay with that, then we're just going to go ahead and stop right there, and we're going to wrap everything else up the next time I see you in class. Until then, have a nice day. You're all wonderful people. Take care.